Sure.
Like, yeah, it's just plugging into graphic, like the graphing calculator, and then coming up with exponential regression. So it's just a bunch of number pushing, or button pushing.
Okay.
So it would be that. Alright. Do you have the meeting ID for?
Yes, I do. Excuse me. 131.
131?
160.
Okay.
437. And I have us going through problem 50 last time. So we will want to look at 51 here. Let me blow it up just a little bit. Okay. Remember that questions about arc lengths are really questions about circumferences. And questions about areas of sectors are really questions about area of a circle.
Alright, so
what would the circumference of the circle be if that arc length is 6 pi?
So, so the total is, so it would be 36 pi, because 30 goes into 186, right?
Well, except how much is the whole circle?
180? Or?
360.
Yeah, oh wow, okay, sorry.
That's right.
Okay, so 12 times 6, so it would be
72 pi, but that's just part of the problem. In other words, the circumference equals 72 pi. Well, if you know circumference, you know radius. And if you know radius, you can figure out the area of the whole circle. And if you know the area of the whole circle, you know the area of this sector is 1/12 of that. So, let's figure out radius. Circumference, what's the general formula?
Isn't it pi times the diameter?
2 pi r.
Oh, isn't that?
That is pi times the diameter, but I think it's actually more helpful to remember it as 2 pi r, and I don't say that about very much stuff. In other words, usually I'm all in favor of 2 letters instead of 1, but not in this case. In this case, I prefer remembering circumference as 2 pi r, because everything there is to know about a circle has to do with its radius, not anything else but its radius. So if you know its radius, you know its area. If you know its radius, you know its circumference. If you know its area, you know its radius. And if you know its circumference, you know its radius. So in this case, we know its circumference is 72 pi. So what is its radius?
So then, the radius would be 36.
Now, what is its area?
Okay, so 2 pi, or pi r squared.
Okay.
So 36 squared
Divided by what?
Divided by...
There's the pi r squared. That's the area of the full circle.
And then this is only a 12, so divided by 12.
Yes.
So 108 pi.
Good. Notice what we had to do with that. That's an excellent problem. It's a hard problem. It's one of the harder problems. But it certainly isn't hard enough to do. It's just got a lot of steps in it. But every step in this problem is critical for solving problems on the ACT. In other words, giving you an arc length and a part of an angle gives you the whole circumference. Gives the whole circumference, you get the radius. Give the radius, you know the area. Give the whole area, you know 1/12 of the area. That's the process on that problem. You might get a lot of questions that ask you about any particular part of that question. But if you can do this question, you'll be able to do all of the others you get, because that involves it all.
Okay, sorry, the phone's breaking up again.
Okay, no, I'll try to be. Let's see, what could be going on there? No, I suppose we could try. You want to try clicking on using mic and speakers?
I'm on a computer that doesn't have a mic right now.
Okay, so we can't even try that. Okay. Well, we'll just have to make do with what we have here. So they're saying 6a to the 5th, b to the 7th is less than 0. Which of the following must be true?
G? No.
Yes, it is G.
Oh, it is?
Uh-huh.
Okay.
For one thing, if A was negative and B was negative, they would still be negative after taking them to the 5th and 7th power, and then when you multiply negative by a negative, you get a positive. So they cannot both be the same sign. They have to be opposite signs. One of them has, in other words, in the end, that and that have to be opposite. The only way you get that is with G.
Okay. Okay. Is there a way to do this besides listing out all the numbers?
You know, there's only 5 days.
Yeah.
So it's not that hard to list out all the numbers. There is a way to do it without listing them all, and if they'd have said 50 days, it would have been a different problem altogether. But first day, how many does she want to see?
7.
Second day. Third day.
13.
Fourth day.
15.
And fifth day.
19.
What's the solution? Without even a calculator. Look at the answers. What's the solution?
It's going to be 9, 8, 7. Wait, so 8, okay. So it's going to be, oh my goodness.
Now stop for a moment. When I ask that question, is all you have to do is add up the tens digits. You don't have to look at the units digits.
Really? Wait.
Yeah.
Oh, yeah.
Because of the answers. Only because they have such a wide spread of answers. There's only one answer in there that's even close to that, and it's 65.
Yeah.
And the reason I know is because I just added up those 4. That's 40. Well, that eliminates 35 and 19, and it certainly is not 105. There would have to be more than 5 numbers, each one of them more than 20 for it to be 105. So I don't have to do any arithmetic at all. It's C. And that's probably the fastest way to do it, rather than trying to figure out what that formula is and applying it. What is the smallest possible value for the product of 2 real numbers that differ by 8? Well, what are 2 real numbers that differ by 8?
14 and 6.
Okay, I was going to use small. I'll use small. It's always good to use smaller ones.
Yeah.
What's the smallest possible value for the product? Well, this is 20. But we could have 1 and 9. That's only 9. For 2 real numbers means we can use negative numbers. We don't have to use positive numbers.
Is 0 considered a real number?
It is. It's not one of the answers, unfortunately.
Yeah.
In other words, 0 times 8 would be 0, but that still isn't the smallest.
Okay.
So obviously our answer is one of those 3. Well, since it's talking about smallest, can we, minus 16 is smaller than minus 4, so can we get minus 16?
Well, yes, right?
So once I get minus 16, I don't really have to consider any other possibility. In other words, this is really a back-solving problem, which I can speed up by starting at the smallest possible number, that. In other words, if I could start this problem up and find 2 numbers that differ by 8 and multiply to give you this, I'm done. I don't have to consider anything else. I didn't do that. I started off with positive numbers just to get an understanding of the problem. But after that, when you're trying to consider which of these negative numbers, well, once I find something that produces that, I'm done.
Right. There's so many tricks you have to remember.
Well, always remember when they ask about smallest or largest, if you're going to back solve, if they'd have said what's the largest, I'd have started here.
Yeah.
But if they say what's the smallest, I'm going to see if I can produce that one right there. Remember, we are getting to the hard part of the test. In general, the last 10 questions on these tests are by far the hardest. So we are approaching that. Oh good, a trig question.
Sorry, the phone's getting weird again. It's like every other word.
Oh, it's okay. I said, oh good, a trig question.
Okay. I think the screen's frozen.
Oh gosh. Screen and audio, that's hard to beat.
Yeah. So it's kind of weak, I guess.
Okay. Let me read it to you. If the cosine of x is equal to 4/5, what is the sine of x equal if we are in the first quadrant?
Okay. So, oh my goodness. Just everything just happening. Okay, I got the screen back.
Okay.
Alright, so,
This is actually a very standard trig question and has a very easy solution. Whenever they give you the trig function of an angle and ask you about another trig function of that same angle, is all you have to do is draw a right triangle.
Okay.
And label x. Now start dimensioning that triangle for me based on the fact that cosine of x is 4/5.
So the adjacent is going to be 5, and then the hypotenuse is, or the adjacent 4, hypotenuse 5.
Okay?
And
Now use the Pythagorean theorem to come up with this side.
yeah, so it'll be 25 minus 16. So 3? Oh yeah, 3, 4, 5.
Good. I'm glad you noticed. And what's the sine of x?
So the sine is going to be 3 over 5.
Right. Notice you could give me any of the 6 trig functions at this point. In other words, once they've given you this, that allows you to mention 2 out of the 3 sides. You can always dimension the third side using the Pythagorean theorem. Once you have the full triangle dimensioned, you can tell me what the tangent of x is, the cosecant of x, anything. This, as long as they tell you first quadrant, that's what tells you first quadrant. So you hope they give you a problem like this.
Yeah. That's easy.
What would the answer be if they said it was fourth quadrant?
Wait.
Do the problem exactly the same.
Yeah? Then,
So you still come up with 3/5, but knowing it's fourth quadrant, what is the plus or minus sign going to be?
so it's going to be a minus?
Correct, because sine is minus in the fourth quadrant. Remember, all students take calculus. So all trig functions are positive in the first, only sine in the second, only tangent in the third, only cosine in the fourth. And of course they're reciprocals. In other words, the cosecant of x in the fourth quadrant would be minus 5/3. If I told you cosine x was 4/5, and we're in the fourth quadrant, and I said, well, what's the cosecant of x? Well, you know that it's 5/3, but it's minus because it's fourth quadrant. In other words, it has to, because it's the reciprocal of sine, has to share the same plus or minus sign. Just to translate that, all students take calculus into all 6 trig functions.
Okay. That's cool. I like little memory tricks like that. So.
Yeah. Had you not heard all students take calculus before?
Never heard that before.
Really? No, that's a great one, because when you get to trig, they're going to try to get you to memorize the unit circle. And they're going to break that unit circle up into 16 spots. And they want you to memorize the trig function of each of these 16 spots. And I think that's a horrible way to approach trigonometry. We don't memorize stuff well, 16 things at a time.
Yeah, make it as difficult as possible.
Well, it's just not a good way to memorize. If I gave you a 16-card credit card number, you wouldn't memorize it as a 16-card digit. You'd break it up into 4 sets of 4. You'd memorize 4 digits, 4 more digits, 4 more digits, 4 more digits, you know, if your life depended on it. Well, trig's no different. as long as I can produce every trig function at every slot here by my method, and my method never depends on you memorizing more than 4 things at once. One of those 4 things is all students take calculus. That puts the sign on it, plus or minus, automatically.
Okay.
All right, let's look at this problem here.
Okay, so every dollar decrease. Oh, wow, okay. Wait. X is dollars per set of books.
I hadn't figured this one out yet. Let's see. For every dollar decrease, a bookstore sells 1,200 more sets of books per month. They normally sell $17.50 at $9.50 per set of books. Okay, so they sell $17.50 times $9.50, right? That's their current revenue. And if we let X be the dollar decrease per set of books, still trying to figure it out. 1,200 more sets of books per month for every dollar decrease. X equals the dollar decrease per set of books. So it seems to me we're going to sell $17.50 times $9.50 minus, no, we're going to sell more. We're going to sell 1,200 X, because for every dollar we decrease it, we sell 1,200 more books, but this becomes $17.50 times
You can't backsolve this one, can you?
yeah, you can, and I was just almost there, and that's not a bad way to do it. Let's do it, because I'm having a hard time coming up with this expression, and backsolving is going to answer it for sure. So, pick an X, and let's figure out how many books he sells. And then we'll go through all 5 answers and figure out which answer is that many books. Notice the answer is asking about the numbers of sets of books sold, not the total revenue.
Yeah.
I'm trying to figure it out as total revenue. No wonder I can't come up with an answer. So if X is 0, what's the answer? Just thinking about the problem. Just think about the problem for a moment. In other words, if you don't change the price at all, how many books do you sell?
You sell 1,750 sets?
Right. Well, notice that that gives you that answer, and so does this give you that answer.
Okay.
If I make x 0. This does not, but this does also. So we got to let x equal something else. Let's let x equal $1. So x equals 1. How many sets of books am I going to sell?
I'm going to sell 2,950.
I'm going to sell 1,750 minus, plus 1,200. So 2,950. That's if I decrease the price by $1. Which answer is that?
Number F, or letter F.
Well, it's certainly F. It's not G. So we've eliminated between those two. Is it K?
No, because K concerns.
Correct. We already ruled out H and J from the previous attempt when we picked 0. So when you're picking numbers and let's say the first number we picked was 0, and we could not distinguish between F, G, or K. Well, when we go back and pick a different number, like 1, we only have to consider F, G, and K. We no longer have to consider H and J anymore. We ruled those out with our first number. So when we pick 1, that rules out G and K. Means F has to be it. And picking numbers by far was the best way to solve that. I could probably go back and given a couple of minutes I could come up with why that's the expression. But as you can see, it's not that easy to come up with that algebraic expression, but it is pretty easy to come up with how many books she's going to sell based on a given X.
Yeah. Okay.
All right. Should we end it? Should we end it there?
Yeah.
Is David around? If he is, we'll just leave the same connection. He and I are going to go at 4 now instead of 4:30 like we used to.
Okay. Hey, David, are you ready? Oh, sorry, I don't know where David went. 1 second. David! Hello?
Hi, David.
Hi, okay.
We're going at 4 today, is that right?
What was that?
4 o'clock okay for today? We had
Yeah.
talked about switching our time from 4 o'clock, so as long as I have the connection open here and you're around, I figured I'd just have your sister get you.
Yeah.
That works? Okay.
Mm-hmm.
We doing the same thing today, going through the algebra, or you got any classroom problems you want to deal with?
Algebra.
Okay. Actually ran into a student the other night that is taking this course, the Big Ideas Learning, the algebra book, the one we're in.
What was that?
And he's doing the algebra. He was a 8th grader, so he was using this book right here. He was on chapter 7. I said, I'm only on chapter 5. Let's go to chapter 6. We kind of are done with chapter 5. So let's talk about exponents. These are always fun. Do you know about exponents? Do you know that 3 to the 4th times 3 to the 3rd is equal to 3 to the 7th?
Yep.
Okay, let's go straight to the exercises. Skills review. Glossary flashcards. They always puzzle me with the way they break these chapters up. Let's see what flashcards are. Somehow, that's not what we want. Skills review. No, that's not what we want. Fair game review 6.1. That looks like kind of what we want, huh?
Yeah. Well, yeah.
Well, this is radicals, not exponents.
Yeah.
Well, let's do these anyway. This is all kind of similar. How about 3? You know how to find the dimensions of that square if its area is 64 square feet?
Well, if it's 64 square feet, then it's just 8.
Okay, how about number 4?
12.
And how about number 5?
Number 5 is... I'm not sure what number 5 is. 1 second.
Okay, well let's look at number 5. Don't do it on your calculator.
Okay.
When you found the first one, you took the square root of 64. When you found the second one, you took the square root of 144. So we need the square root of 9/16. Well, by the rules of radicals, that's the same as the square root of 9 over the square root of 16. So what's that number? What's that number?
It's 3/4.
Mm-hmm. Notice that when you take the square root of numbers less than 1, they get bigger. 3/4 is a bigger number than 9/16. 9/16 is barely more than a half. And that's always the case. If I take the square root of 4, I get 2, which is a number greater than 1. But if I take the square root of 1/4, I get 1/2. This is bigger than that.
Okay.
Okay, so that's a good thing to remember about square roots. All right, let's look at some of these expressions. Simplifying these radical expressions. Square root of 18. The trick is to factor that number and try to find a factor of that number that is a perfect square number.
What's the square root of 2?
Just that. In other words, once you get it down to the square root of a prime number, you can't reduce it anymore. And in fact, the rules are that you only can reduce this if you can pull out a whole number. In other words, that's the square root of 9 times the square root of 2, so this is 3 root 2. Okay? Square root of 10 is the square root of 5 times the square root of 2, but there's no whole number to be pulled out, and it's 2 terms instead of 1. So this is not simplified. This is simplified. Square root of 10 is the answer. So that's what determines on whether it's not always breaking it down, it's being able to pull out a whole number is the key. Okay?
Yeah.
In other words, this would be the correct answer, and this would be the correct answer. So, for minus square root of 200, what's that equal to?
Well, square root 200, if you get, if you prime it,
You don't even have to prime it all the way down. Sometimes that's a lot of unnecessary work. Just figure out two factors. What's one of them?
10.
Okay. 10 times 20.
Oh, okay.
That doesn't help us much because neither one of these is a perfect square. So figure out two other factors of 200. The trick is to find any perfect square. Any perfect square you can find will work.
No, 50 wouldn't be a perfect square.
How about this?
Well, 2 isn't a perfect square.
No, but 100 is. You're not always going to find two perfect squares. Then that whole thing would come down to a whole number. But in this case, 100, because it's a perfect square, it becomes 10. We know that's simplified because you can't get any simpler than root 2. In other words, when you get root of a prime number, there's no way it factors down any more than that. You with me so far? Notice that you don't have to be perfect on your first try. Let's say 50 and 4, which multiplies to be 200. Well, that's a perfect square. So I could say minus 2 root 50, but that's not simplified because root 50 is root 25 times root 2. And root 25 is a perfect square. So now I have minus 2 times 5 times root 2, or minus 10 root 2. In other words, if I'm not perfect on my first attempt, it doesn't matter. I could have separated this into, as long as I have a perfect square in there, I can keep whittling it down so that I eventually get to your final answer. It's always a shorter process if you happen to be able to pick out the factor that is the maximum perfect square, which in our case is 100. There's no factor of 200 that is a bigger perfect square number than 100. And that gets us straight to this immediately.
Okay.
About square root of 12.
So the square root, well, you have 3 and 4. 4 is a perfect square. You get 2, and then the square root of 3.
2 root 3. You may not quite be there yet, but you're going to reach a point where they say root instead of square root, just to be more efficient. It's root 2 or root 3 or root 5. So what is root 48?
Square 48 is, well, it would just be
The best way to do these is to memorize what your perfect square numbers are. Starting with 1, give me the perfect square numbers.
1, 4, 9, 16, 20, 25, 36.
That's about all the further you need to memorize.
Okay.
because it's rare that something's going to be divisible by 36 or 49. So these are usually the numbers you're always dealing with in that area there. So is 48 divisible by any of those numbers?
It's divisible by 4.
Okay, let's do that one. Square root of 4 times what?
Times 12. And then you get 2 root 12.
Now is root 12. Can you break it down? We just did the previous problem.
Yeah, 3 and 4.
So that's 2 times root 4 times root 3, which is 2 times 2, so it's actually 4 root 3. Well, that means we must have missed the maximum perfect square. Which of these numbers over here on the right is the maximum number that divides into 48?
Yes. Wait, 16.
16 goes into 48 exactly 3 times. So if I'd have seen that, I'd have gotten to the answer immediately.
Oh.
But it's not really a game of how fast you can get to the answer. It's merely a game of can you get to the answer.
Yeah.
So don't worry too much about getting there in one step. It's not worth the effort to try to see if this number is divisible by all these bigger numbers. The toughest one to see is that, because it's hard to see numbers that are divisible by 16 for some reason. How about this one?
That's divisible by 25 5 times. So you get 5 root 5.
And we don't have to worry about that because that's prime. Once you get prime, there's no way that it can be reduced any further. Minus 23 over 64. So let's do the first step. What's the first step? Separate it into the quotient of 2 square roots.
Yeah, root 23, root 64.
Divided by root 64. And I have to put that negative sign somewhere. I could put it out in front, I could put it on top, I could put it on bottom, it doesn't matter. Now how do I reduce that?
You get root 1 over the other, since 23 is prime. You can't do anything with that.
There's your answer. And that's exactly right. Now, let's talk about
Well, since both of those are prime, you can't really do anything.
correct. So that's equal to 1 over root 2, right? Square root of 1 over square root of 2, square root of 1 is 1.
Yeah.
Problem with this answer is there is a convention in mathematics that says you never want an irrational number in your denominator. Well, square root of 2 is irrational. Any root, in other words, irrational means you cannot express it as a fraction. Square root of 2 is equal to 1.41 ... on forever. So there's no way to express square root of 2 as a fraction. That makes it irrational. That means you cannot leave it in a denominator like this. Well, what do we do when we have an irrational number in the denominator? We have a process called rationalizing the denominator. And what you do is, since you can multiply any fraction by the number 1 without changing its value, I'm going to multiply this one by 1. only my 1 is square root of 2 over square root of 2. Well, when I multiply the numerators, I get square root of 2. When I multiply the denominators, I get 2. So this is an acceptable answer. So these two numbers are exactly the same. It's the one on the right is mathematically acceptable. This one is not. And that's really all you need to know about rationalizing the denominator. So what is this equal to?
Maybe I got kind of lost.
Okay, what do we need to multiply the bottom by in order to rationalize it? So if we're multiplying the bottom by root 3, we've got to multiply the top by root 3. Because we can only multiply a fraction by 1 without changing its value.
So you have root 3 over root 9.
Which is 3. Always remember that root x times root x is x. Okay? So in general, this is the way it works. 1 over root 5 is root 5 over 5. Notice that 1 over root 4 is root 4 over 4. Even though that's 1/2, that's also 1/2.
So you just multiply the numerators as a number in the root, and then...
Yeah. It's good to know what you're doing, though. It's good to know that you're multiplying this by root 3 over root 3.
Yeah.
So 2 over root 3, I would do exactly the same thing. Now my answer would be 2 root 3 over 3. That also has a rational denominator. Okay? Minus 65 over 121.
Well, you do square root of 65 over square root of 121, and you get, right now I'm not quite sure 65 can be squared.
Well, we know it can't. In other words, we don't know if that's simplified. What's root 121?
11.
So, at worst case, it's this. Now, 65. Are any of those numbers that I wrote down factors of 65?
No.
And if I keep going up, it's not going to help, right? So 65, the best I could do would be 11 or 13 times 5. That, if I break it up into that, I know that I can't simplify it because these are both prime. In other words, if you take a number and you split it up into two prime numbers, and that means that's the only two factors of that number. Okay? In other words, if I said square root of 21, well, I know that that's square root of 7 times square root of 3. Because that's prime and that's prime, I know that there are no other factors of 21. I don't even have to check. That makes that the best. That's simplified. Same thing with 65. If I can't find a perfect square number as a factor of that, then it's simplified. I don't want to write that as square root of 13 times square root of 5. That would be 2 terms instead of 1. Of course, I still need my negative sign, but that's the right way to do that problem. About 13. Square root of 18 over square root of 49.
Well, if you take the square root of 18 times the square root of 40. Well, it'd be 3, and then root 2, and then 7.
Good. 14.
That's easy. It's 5, 6.
Evaluate that expression when x is minus 2, y is 8, z is 1/2.
Okay, so x is minus 2. That means minus 2 squared, so negative 4. No, 4. Plus 4. And you get 8. So you get square root of 2 times square root of 2 times square root of 2.
Well, let's not do it that way. That's not a bad way to do it. I see why you did it that way. But let's do it this way. Because there's my perfect square number. Okay? You see why root 8 is 2 root 2? It's also root 2 times root 2 times root 2. Put those two multiplied together give you the 2. So that's why you end up with 2 root 2. Okay. I think you're good with these. I don't think you need to do these two over here. What the heck? Let's do them anyway. 16.
So that one, well, you get 4 times 2, you get 8 plus 54 squared, and then, so yeah, that's 72, and so 36 goes into
Good. Good. Not everybody would see that.
Yeah. So square root of 36 times 2, and that's, 6, and then root 2.
Okay. Now notice that if I didn't see the 36, I'm still going to get there. In other words, as long as I can see that that's divisible by 4, and that's the square root of 4 times the square root of 18, that's 2 root 18, but 18 is 2 root 9 times root 2, so it's 2 times 3 times root 2, or 6 root 2. In other words, you can always get there using a smaller perfect square. You just take more steps. This is the process I call whittling it down. I pull out a 4, I pull out another 3, and so forth and so on. But as long as you see the 36 immediately, clearly that's the faster way to do it.
Okay.
Let's see what else we got here. Simplify the expression.
So you get 6 plus 2 plus root 11. And then that comes out to 8 root 11 divided by 2. So you get...
Hold on. You can't add 6 to 2 root 11. That's apples and oranges.
Okay.
If I had 3 root 11 plus 2 root 11, I would have 5 root 11. What I can do is separate this thing into two numbers, that number and that number. In other words, I can divide top and bottom by 2, which gives me 3 plus root 11. There's my answer. Okay? In other words, I divide, if I separate it into two fractions, there's where I get my 3, and in this fraction, the 2's cancel, and there's where I get my root 11. Minus 7 minus root 98 all over 7.
So, the step there is, technically, couldn't you split that up kind of and get negative 1 times negative root 98 over 7?
It's not times, it's subtract. So yes, that is a legitimate first step. Now what can we do with this part of it over here?
Well,
Think of your perfect square numbers. Are any of them factors of 98?
no, not 4.
No?
No,
About 49.
49. Oh! That's actually counted it so far.
Well, there's a good reason to think of 49, because we're looking at a lot of 7s. I mean, not that that's always going to be the case, but at this level here, you can imagine that a 7 might come out of that. So that would be square root of 49 times root 2 over 7.
Yeah, and 7 root 2 over 7.
So you get minus 1 minus root 2. That's the answer. And yeah, that first step was not a bad one to take. You don't have to do that as a first step, but it works just fine.
Yeah.
All right. Let's call it a session. I think we covered this stuff pretty good, actually. It would have been worth covering these problems here. Let's just do one last problem before I let you go. What's 29?
So, I can't,
Square root of 42 x squared y squared.
Well,
Do the numbers first and the letters second.
So,
Square. In other words, the first step I can do automatically is this.
Oh, okay. So the square root of 42 is not divisible by 16, not 36. Obviously nothing higher than 36.
That means that's our answer.
Yeah.
It's the square root of x squared.
And then the square root of x
And what's the square root of y squared? What's the square root of x cubed?
X squared?
Well, it's the square root of x squared times the square root of x, right?
Yeah.
Which makes it x root x.
Oh, okay.
Alright, yeah. Alright, this is good stuff here. This is definitely stuff you have to know. I mean, sometimes they give you a lot of stuff you really don't have to know, but this stuff's good. Definitely have to know this for higher mathematics, all of this stuff.
Yeah.
Alright. Good working with you. I will talk to you next Wednesday at 4.
Yeah.
Alright, David. Have a good week. Have a good week. Bye-bye.
You too.